frequency of the antenna, mixer, and oscillator stages in the UHF tuning device. In the newer television sets, electronic tuning is used almost exclusively, which provides no moving parts within the tuner section. This is accomplished by a special component known as a varactor diode or voltage variable capacitor. Here you see the schematic symbol for this device. As you recall in the You Can Do semiconductor video VT203, whenever a PN junction is reverse biased, a depletion region is established in the midst of the junction. The higher the voltage potential of the reverse bias across the PN junction, the wider the depletion region. This depletion region acts like the dielectric in between two plates of a capacitor. In the case of the varactor diode, the two plates are the P and N type materials. As the reverse bias voltage is increased across the PN junction, the depletion region widens over the PN material. Both PN type materials now have less effective plate area and are effectively spaced further apart, decreasing the capacitance of the device. The decrease in capacitance increases the resonant frequency of the associated tuned circuit. So as the reverse bias voltage increases, the frequency of the tuned circuit increases. Here you see a tuner module utilizing varactor diodes. Notice that the RF mixer and oscillator sections each have a varactor diode to properly tune each stage. Since all three stages must be tuned at the same time, a different form of ganging must be used. With no moving tuner parts, mechanical ganging is out of the question. Therefore, electrical ganging is used. Notice the electrical line connecting the cathodes of each varactor diode. This line is used to simultaneously adjust the capacitance in each stage. Since a specific voltage represents the same capacitance to each of the varactor diodes, all three varactors are a matched set. We will now pause for a short review of the material just discussed. A change in frequency can be accomplished in one of two ways. Either the inductance changes with the capacitance remaining fixed, or the capacitance changes with the inductance remaining fixed. In the older television sets, a tuner drum, composed of 13 sections, would mount a set of tuned coils for each of the antenna, RF amplifier, mixer, and oscillator stages. The channel knob turned this drum to the correct section of coils for each TV channel. The last setting switched to the UHF band of channels. The last three wafers of the wafer switch contained a series of coils wired end to end. As the wafer switch turned each channel setting, more or less inductance would be added to the rest of the tuned circuit. As the channel setting increased, less inductance would be placed into the circuit, which would increase the frequency of the circuit. The first wafer contained individually mounted coils, especially for the oscillator stage. Usually, air variable capacitors were used for tuning through the UHF channels. Each antenna, mixer, and oscillator section consisted of two types of tuner plates, fixed and variable. One or more variable plates was made to rotate parallel to one or more fixed plates to adjust the frequency of its tuned circuit. The varactor diode makes solid-state tuning possible. The varactor diode, or voltage variable capacitor, uses a reverse bias condition to establish a depletion region which acts like the dielectric within a capacitor. The degree of dielectric opposition within the PN-type material changes the capacitive characteristics of the diode. The varactor diode can be placed into a tuned circuit and used to change the resonant frequency simply by varying the degree of reverse bias voltage. This concludes review number 3. Now stop the video and complete section C in your student workbook. In this part of the video, we will examine the